this is string P, string Q and R. Here now, if the system above is in equilibrium, we have to calculate the tension in string Q, tension here, tension in this string. So what we are going to do here now, you look at it very well. This is R, the load on R, the load on Q will be 4 Newton and 5 Newton. So the tension in Q will be 4 Newton plus 5 Newton, and that is 9 Newton. That is the amount of tension on this cube. So we are going to combine this together with this to give us the tension. So the tension in P will be 5 plus 4 plus 2 to get the tension in P. So the tension here on R is 5 Newton. Tension in Q is 5 plus 4. So this load plus this load will be the more tension on this on Q. So the tension on P will be 5 plus 4 plus 2 will be the tension on this P, while the tension on this Q will be only 4 and 5, and this 5 Newton is the tension on this R. In the figure above, the work done by the first 100 Newton inclined at an angle of 60 degrees to the object, dragged horizontally to a distance of 8 meters is what? So here we are neglect frictional effect. So what we are going to do now to solve this problem, let's draw the force diagram here. So we have, assume we have this. Now we have this. This is the weight. Look at that. Then here, look at this. So if incline at 60 degrees, then if you have this, we are going to resolve this into components. We have vertical component and horizontal component. So we have this one, and this will be the, here the force. Here we are going to have 100. The force, this is 100 Newton. So 100. This is cos theta. That is this angle that is going to be cos 60. So as we have this, that our F equal to this. So F cos F sin theta. So with this, if I draw this very well now, I'm going to have the work done equal to force times distance. Work done is this weight. The work done equal to force times distance. So if you have to calculate this force, the force to move, so the force to move this forward here is going to be 100 cos 60 degree. That's 100 cos 60 degree. So and F now equal to 100 times 0.5. That is cos 60. That is 1/2. Cos 60 is 1/2. That is 0.5. So this our F now gives us 50 Newton. So it is this we are going to substitute here to find the work done, to draw it horizontally. Horizontally. Look at this. To draw it horizontally. So this is horizontal force. Then the work done now equal to 50 times 8. Then the work done equal to, if you multiply this and this together, so 5 times 8 give us 40. then for this 400 joule. A boy drags a bag of rice along a smooth horizontal floor with a force of 2 Newton applied at an angle of 60 degrees to the floor. Calculate the work done after a distance of 3 meters. To answer this question is very simple and straightforward. So the first step to take is to draw the diagrams. That is the horizontal floor. This is the bag of rice. Then we look at it very well. When you have this, you have the weight, then we have the force, the horizontal. At an angle, the force is applied at an angle, so of 60 degree, angle of 60 degree to the horizontal. So horizontal, if to the component now, you look at it. So we have 2 cos 60 degree, while here we have 2 sine 60 degree. So same thing as this. So I can draw it. I have horizontal, I have this bag of rice. The force to move it up is 2 sine theta times 60 degree, while this is a 2 cos 60 degree. So this is the force to move it along the horizontal. That's the force. So the force to move in it, our force to move the bag of this rice along horizontal floor is 2 cos 60 degree, and that is 2 times 0.5, because cos 60 is 0.5, and this is 1 Newton. So that is the force, but we have to calculate the work done. So to calculate the work done equals force times distance, force times distance. So, and this force is 1 Newton times 3 meter, and that is going to give for 3 joule. So that is 3 joule. A bulb of weight 0.1 Newton hangs from a massive string of length 50 centimeter. A variable horizontal force which increases from 0 is applied to pull the bulb until the string makes an angle of 60 degrees with the vertical. Calculate the work done. Okay, to answer this question, let's start with step by step. Now, if you look at it very well, the length, let me draw this first diagram. This is the fixed, and from here, see we have 60 degree. This is the bulb. I have the bulb. This is the bulb. If you look at it very well, from here we have our force here. So we have the weight of this bulb. Then we can have this. So with this now, we are given that the length which is from here to here, the length is this length is 50 centimeter, which is the same thing as 0.5 meter. No, 100 centimeter make 1 meter. So we convert it to SI unit, that is meter. So with this, we can actually get the value of this. So I can draw this out. So this weight is the same thing as this. So our weight, which is also the same thing as as 0.1 Newton. This is about the weight of this bulb. So I can bring this out now. I have this. I have 60 degree. 60 degree. This is a 60. This is 0.5. This is 0.5 sine 60 degree. 0.5 cos 60 degree. Now, with this now, we can now realize that this bulb move this way. Move this way. Look at that. Move this way. From here to here. So if this, let's say this place is H, this place is a 0.5 cos 60 degree. I can label this one an A, let's say B, then C, to point C, like this. So from here now, we discover that this, our A, B, C, the length here is equal to 0.5 from here. So I can now see from that then now from here we need to calculate the value of this H. So making 0.5 equals 0.5 cos 60 degree plus this H plus H here plus H. Then if you look at it very well, can make this solution making H equal to 0.5 minus 0.5 cos 60 degree. Then this 0.5 minus 0.5 times 0.5, because this cos 60 is 0.5. So from that, this equal to 0.5 minus 0.25, and with this I'm having 0.25 meter as our H. That's 0.25 meter as our H. So as you know the value of this H now, it's not very easy for us, because to find the work done. So because our work done here, the work done here equal to potential energy, which is same thing as mgh, and so therefore our work done equal to potential energy, same thing as mgh, meaning that this is 0.1 times 0.25. as we have this one now here, this our mg as the weight here 0.1, which is given in the question. So these are 0.1 times 0.25, the value of this H that we got from here. Then that is 0.025 joule. 0.025 joule. That's the final answer here. An object of mass 80 kg is pulled on a horizontal rough ground by a force of 500 Newton. Find the coefficient of static friction. Let's answer this together. If you look at it very well, you see this horizontal. Then we have the log. Remember, this is our frictional force. So our frictional force. While this is our 500 Newton. Now, something is happening here now. The mass is 80 kg, while our force is 500 Newton, which is this. So at the verge of moving, at the verge of moving, verge of moving, this equal to this. Frictional force will equal to 500 Newton. So when it's about to moving, at the verge of moving, so it's equal to this. And remember, this is this is coefficient of static friction times mass times acceleration due to gravity. So with this is equal to 500, and m is 80. So going to be this times 80 times 10 equal to 500. Remember, this acceleration due to gravity. So g will equal to 10 meter per second square. That is acceleration due to gravity. So, and this now equal to 500 over 800. So if I cut this, so this equal to 5 over 8, and as we have that, coefficient of static friction will equal to 0, 5, then 6, 2, then 5. So that's 0.625, and this is approximately equal to 0.6 to 1 decimal place. If a heavy barrel is rolled up a plane inclined at 30 degrees to the horizontal, what is velocity ratio will be? So to answer this question, let's draw the diagram. This is the inclined plane at 30 degrees, and this is the object on it. So as you have this one now, you agree with me, and we have the velocity ratio equal to 1 over sine theta. And as you can see, we have been given theta to be 30. So therefore, our velocity ratio equal to 1 over sine 30 degree, and this is equal to 1 over 0.5, that is sine 30. Then our velocity ratio equal to 2. That's all. A body of mass 4 kg resting on a smooth horizontal plane is simultaneously acted upon by two perpendicular forces, 6 Newton and 8 Newton. So to calculate the acceleration of the motion, so it's very simple. Let's solve this together. So the first thing now, let's draw this, the object is being acted upon by two forces with perpendicular, look at that, like this. So this is the resultant force. The resultant force. We need to calculate the resultant force. So to do this, we are going to have our F squared equal to A squared plus C squared. So F now equal to square root of 64 plus 36, and our force equal to 100, root 100, and that is 10 Newton. So 10 Newton is the resultant force acting on the body. Now, to calculate the acceleration, now we are asked to find acceleration. So our F equal to ma. So therefore our A equal to force over mass. So let's substitute the value. This is 10 Newton over the mass, what you have been given as 4 kilogram. And this now equal to, if you cut this one, cut them 2 into, that is 2.5 meter per second square. So 4 goes in 10, 2 times, remember 2 in 25, that's 2.5. Acceleration of the motion. The resultant of two forces, 12 Newton and 5 Newton, is 13 Newton. What is the angle between the two forces? So to do this, let's represent the two forces using triangle, two sides of a triangle. This is 5 Newton, and this is a 12 Newton. This is the angle between them, theta, and this is the resultant force. The resultant force 13 Newton. So if you look, you can use cosine rule. So having 13 square equals 5 square plus 12 square minus 2 times 5 times 12 cos theta. So it's unknown. That's the angle between the two forces, 12 Newton and the 5 Newton. So this is 169 equals 25 plus 144 minus 2 times 5, 10, 10 times 12, that is 120 cos theta. 120 cos theta. So with this is 169 equal to 169 again minus 120 cos theta. So therefore, being this one here, you have 12 cos 120 cos theta. You have 120 cos theta equals 169 minus 169. When we bring this one here and bring this one here, so this one comes here, this one comes here. Then 120 cos theta equal to 0. So it's now very easy now. Then cos theta equal to 0 over 120. So from that, cos theta equal to 0. So cos 0 over 120 will give us 0. So you can easily find theta now. Cos 0 degree, that's equal to 90 degree. So theta is 90 degree. So that is meaning that the angle is perpendicular. The angle between them, the two of them, they are perpendicular to each other. So the two forces, 5 Newton and 12 Newton are perpendicular to each other. They are perpendicular to each other.